Hello and welcome back to this video on version control, build, and test PowerShell script. You're probably getting at the ninja level with PowerShell already. Over the last two modules, we've talked a lot about PowerShell, and as a sysadmin, you're probably using PowerShell already. Now, in this theme of converging tools using the same best practices of CI/CD, why not test your PowerShell scripts? Why not, run code analyzers on your PowerShell scripts to identify whether they're coded up in the best possible way or whether there is scope for improvement? And what better than using the same development tools that your development team is using to run these activities? So in this video, what we'll do is we'll drop right into Visual Studio, go into Visual Studio Team Services, go into the team project that we'd created earlier. We will clone that project into Visual Studio, and as an operations engineer or as an infrastructure engineer, you may or may not have used a Visual Studio a lot, but the integration is so nice that you're not going to see the friction. And then from that point onwards, coding up your PowerShell functions in there and creating some unit tests for that. And then we'll go back into VSTS, set up a CI pipeline that not only compiles the code that you have for PowerShell, but also runs your tests and then giving you a way of analyzing the test results as well. Okay, so let's flip right into the demo here. Okay, so I'm in Team Services now, and as you can see, this is the project that we created in one of the previous videos. We'll go into the Code Hub, select the Git repository, and then at this point, I can simply select the Git repository and click Clone, and decide to clone the Git repository in Visual Studio. And it's just asking for a confirmation. It identifies the version of Visual Studio that's installed. Behind the scenes, it in the context of cloning specifies the endpoint. I'm already authenticated, so it's not going to prompt for credentials. Um, it's just loading up Visual Studio now. Now at this point, it's confirming whether I want to clone the repository locally on my machine, and I can confirm to do so. Will take a few minutes to complete. As you can see, this activity is completed now, and it's what's great is although the repository is empty at the minute and only has a README file, it's loading it up in the Solution Explorer window. So I don't need to create artificial solution files to put in my PowerShell scripts in there. I could just come in, right-click the repository folder, and decide to add a new folder. Let's call the folder code. And within this folder, I'm going to create a new file of type, let's call it calculator.ps1. So this is a PowerShell file. And as it detects the extension, it figures out that this is a PowerShell script, so the right editor syntax IntelliSense will kick in automatically. So in this case, I'm just going to create a function. And I'm creating this PowerShell function to do something. So let's call it add two numbers. And I'm going to cheat a little bit because I've already created that function. Very simple function that simply does addition on two numbers. Okay, so this function will accept number one, which is of type integer, number two, which is of type integer, and then it's basically going to sum them up and return the results. What I can do now is traditionally I would have just committed this code and I'd be done with it. But as a good practice, I want to unit test this code and want to make sure that this function actually does what it's supposed to do. The other advantage of unit testing this is tomorrow if I come back and I want to extend this library of sum to do something more than just add two numbers, then I've got some unit tests that back this function. And as I refactor the code, I will have confidence because I can simply run my test and see whether any of the other functionality has been impacted or not. So right in here, I'm going to right-click on the code folder, click Add, choose a new file, and call this calculator.test.ps1. Okay. Again, I'm going to cheat a little bit because I've created the test here, but I'll just copy one of the tests and walk you through as to what it's really doing. When you look at the syntax, this is a very BDD style syntax where you're calling uh, the function that you're testing, but you're saying what it is supposed to do, passing the parameters, and then you're specifying what the expected behavior of the result is. So in this case, I'm saying describe the tag demo, right? This is a sum test which adds positive numbers, and I'm calling the function here. I'm passing the input parameters, and this should result in number 5 being returned. So if I now go into the PowerShell interactive window, and if you don't see it, you can type it in the quick uh, navigation search window at the top, and it will load this window up for you. I'm simply gonna change directory to where this repository has been cloned. So copy this path and do a cd paste. Uh, Now, if I go in this directory, I can see, I've got the code folder, so on and so forth. So let me just change directory into code. Let's do a directory. Now I'm in the same directory as where my code is and my tests are. At this point, I'm going to start using Pester. Now, we talked about, or we mentioned Pester before, but you can search for it online. Pester is a unit testing framework for PowerShell. Very, very supported in the community. You'll find a lot of examples on it. So let me just invoke Pester here. And you can see the support for that is available right within Visual Studio. When I run invoke Pester, and it doesn't work. The reason it doesn't work is because the default behavior is that it expects the test file to have the keyword test, not just test. If I make that amendment now and run this test again, there you go. It finds the test, which is describing sum plus add positive numbers, and it's even giving you the telemetry on how much time it spent executing that line of code, completes the test in 38 seconds, the test has passed, and great. So fairly easy, right? I mean, I was able to create a test here. The kind of scenarios I would want to test here is instead of an integer, if I'm passing a decimal, or what if I'm passing negative numbers, or boundary testing. This is a very basic function, but when you're writing PowerShell runbooks to do stuff that needs to be mocked up because they are complex objects, then this framework supports all of that. And the integration with Visual Studio just makes the testing exercise a lot more easier. So I'm just going to copy a bunch of more tests that I have here. And then just save it, and then invoke the command again. Is invoke tester. There you go. It's run all the tests. All the 4 tests have passed. Nothing's failed. Nothing skipped. So at this point, what I want to do is I just want to commit these changes. And let me go into the git changes, adding a function and adding tests for that function. I'm going to commit this, and then I just need to sync this up to the Git repository. So I'll push this, and that operation is completed. So if I go back into the Git repository here now, oops, this one here, and click refresh, you see I've got the code folder, my calculator functions available, and the tests that I'd created are available here as well. Now, what I really want to do is set up a build process so I can not only validate this now, but have it run every time I make changes to this repository. So I'll choose to click a build definition here, and let's select an empty process. Let's get the sources, let's select the right repository, selected the right branch, and it's able to do that because I triggered the set build process creation task right from the context of my Git repository. So it's already able to preempt the right configuration details of that Git repository. Coming back here, let's add the task for PowerShell. And let's add the task for Pester. Now, you'd find that Pester might not be available within your VSTS solution. That's because Pester isn't available as a task that's provided by Microsoft. It's a task that's available from the open source community. Again, if in your product you create the right APIs and you create an ecosystem, then people will come and contribute to it. And this is a classic example of that. If I browse to the VSTS marketplace, let's just try that again. from here, browse marketplace, and look for Pester. You see, I've got a couple of options here, and both are open source. You come in here, you can see, you know, it's gone through certain evolution. It was quite basic. It was just able to run the test before, only supported a version of PowerShell, and it's since been upgraded and updated and provides a lot more features now. So going back in here, I'm gonna just add the pester task, which we've added from the marketplace. In my PowerShell script, I'm going to select the script that I just want to exercise. In this case, it's the calculator function. And in the pester test runner, I'm not going to make any changes because the default values are good enough. It's going to look at the build output, build location, identify anything that has, you know, that is a test file, and then simply pick it up. So let's just save this, call it PowerShell CI, click save, and now queue this build. This should be pretty quick. It's just waiting for the hosted agent to be available so that it can schedule this build on the hosted agent. The build's been picked up by the hosted agent. It's just taking the code, downloading it. It's run my PowerShell function, and now it's executing the pester test. As you can see here, it's completed the test execution and the build's completed. Now, you know, while all your tests have executed, what would have happened if a test would have failed? It would have been a little difficult to start diagnosing why it failed, because you would have had to go in the logs, look at the exact test that was failing, you know, figure out in the log what the inputs and the outputs were. But in this case, you don't really have to do it because the VSTS testing framework is magically able to pick up the test result file generated by Pester and parse it into a VSTS, and then gives you a way of analyzing the test execution results in a graphical interactive way. Let me show you that. So let's go into the test section. And at the moment, it says that the Visual Studio test task needs to be added because it's unable to find any test results. So in order to make VSTS discover the test results that Pester has generated, I'm going to have to edit the build definition and just add one more task in here, which is called Visual Studio, which is called publish test results. Publish test results, click add. Now, I don't have to make any changes apart from changing the format to NUnit. What it's going to do is it's going to look at the output directory of the build compile folder and then see if it can find any test results that match the following format. And as long as the framework in question can generate the format which is supported by JUnit, NUnit, VSTest, or XUnit, VSTS will be able to parse that result set and display it in a graphical format. So let's just save this definition and queue another build. And hopefully, this time when the tests execute and it discovers the XML file, when we go back into the test section, we should be able to analyze them in a graphical way. So it's acquired the agent. It's just downloading the code. Next up, executing my function. Next up, running the test. And almost done there with the test execution. Now it's looking to find the XML file. It's found it. It's finished the build. Now if we go to the test section, whoa, look at that. You know, you get not only test results, but incremental test results, which means it's tracking the trends of the test execution. What you see here is that no tests have failed. If you change the outcome to passed, then you can see all the individual tests that were executed. It's got code, it's code aware as well. So if you right click this and say open a new tab, it will take you to the test analysis results for this specific test where you can see how much time it spent, and then you can update analysis here. You know, if a test was failing, you could launch a bug creation report from here. And again, that brings in all the artifacts with it. For example, what build did this test fail in? The specifics of the test execution, when was it run? So all this information, if this tool wasn't integrated, if the code wasn't living in the same tool, then you would have had to put in yourself. But the power of integration, boy, this is amazing. So if we go back into the test results here, what it also allows you to do is look at the test execution duration over the last few builds. And if you wanted to monitor this on a dashboard, then you could simply pin this to the dashboard. So if I go back from here into the dashboard for this project, you would see here that a new tile's been added. So if test execution for your PowerShell code or important runbooks is something that the team wants to track, then a widget is available that can simply be put on the dashboard for purposes of tracking. So really, information radiators, integration, all built into this classic DevOps platform. So that's all I really wanted to show you with PowerShell source control, integration with Visual Studio, test execution, CI, and test results analysis. In this module, we've covered quite a journey. We started off by looking at ARM templates. We started using PowerShell ISC to deploy them. We quickly promoted ourselves to doing it through Visual Studio. We looked at DevTest Labs manually again, and then we looked at the automation capabilities within DevTest Labs. We looked at creating templates within DevTest Labs and taking them the whole mile into production. And then we looked at the specifics of PowerShell and how we can use the same tools as the developers use to build a CI test process around your PowerShell scripts. That's the end of module 3, but we'll be back with more exciting stuff in module 4.